heard about the plastics problem. Yeah. And then, so there's too much in the ocean. How does it get in the ocean? It's us, right?
My name is Abigail Ahlert, and I worked with Dr. Georg Proskrowski, Jared Swalwell, and Julian Masura studying nanoplastics. There is a lot of current research going on involving microplastics. And that's what I actually had the opportunity to share with a group of middle and high school age girls on the Tall Ship the Adventurous through a program called Girls at the Helm. And so we actually got to do some net tows and filter some samples looking for these microplastics with these younger girls. I also got to share with them what I've been doing in the lab this summer involving nanoplastics with the flow cytometer. I work with nanoplastics, and nanoplastics are too small to actually be caught by the manta ray net. There's the manta. Is this okay? What I have to do, I've been working on figuring out how can we characterize the amount of nanoplastic in the ocean. If you look at the back of a bunch of face washes and toothpaste, they'll say that they have polyethylene, which is a type of plastic, and they use really small beads to scrub or exfoliate, so anything that says it's got scrubbers in it, that actually has little pieces of plastic, and you are using it in the shower, using it in the bathroom, and washing it down the drain. But that is too small to actually be caught by the wastewater treatment plants, we think. So the face washes that you're using with the plastics in them are going directly into the Puget Sound and the ocean. This is a flow cytometer, and to use a flow cytometer, you insert your sample into the sample line. It's a liquid sample containing the particles you want to study. And then the sample is pressurized and pushed up towards a laser, and the particles in the sample are then interrogated by the laser. Detectors then measure the forward scatter, side scatter, and fluorescence in a given wavelength, and this can be used to determine the number of particles in the sample as well as their relative size. This method is normally used to characterize populations of phytoplankton, but I have been developing a method to determine how to use the flow cytometer to study nanoplastics. Plastics don't actually fluoresce naturally, so we have to stain them. And the whole process of figuring out how we can make these plastics fluoresce so we can count them in the flow cytometer has been what I've been working on this summer. That was really a great experience because I got to not only do the hard science behind the research, but also share that with a younger generation.